A bit of a break from proofs, if that's okay with you guys. Yes. I mean, I can find some in this section, and we can still do some. But all right, either way, download the numbers file from Google Classroom, and let's do this. Okay, so 9192, reflections and translations. I think this will be a fairly simple section for you guys. Okay. Essentially, this whole chapter is about what we would call transformations, which if you've taken Algebra 1, Algebra 2, I know you guys have all taken Algebra 1, some of you guys have taken Algebra 2. You guys do transformations of graphs, shifts, up, down, left, right, reflections, and, enlargement, reduction, that type of stuff. You do that in Algebra 2 as well. So some of this may seem a little familiar. I don't know if you guys get to that stuff yet, but... Okay, so either way, what we're going to do is we're going to take figures, whether they're triangles or otherwise, and we are going to move them around our coordinate grid, okay? For the first part, we're going to do for reflections, and then we're going to talk about translations, okay? If you reflect something over a line, what happens to it? That would be like if you're moving it over a vertical line. So Tegan went like this, and then he went like that. So that would be like a reflection over that vertical line, right? So depending upon what type of line we're reflecting it over depends upon what our figure looks like. Now, when you do a sort of reflection, does that change the size or the shape of your original figure? No, it does not. So we find that reflections create an image that is congruent to our original image, okay? All right, so a reflection is a transformation that represents a flip. That's probably how you guys have thought about it in the past, is the word flip. So it represents a flip of a figure. Figures may be reflected in a point, they could be reflected in a line, or they could be reflected in a plane. Most of what we will do is we will spend our time talking about reflections over a line. We'll do a little bit of stuff where we reflect things over a point as well too, so we'll see that in a second, okay? Now, so far I've referred to these things as like original image and then result, but there's words for each one of those. So pre-image is what we can think of as our original image. So it's the image before a reflection or really any sort of transformation, okay? So we're going to call that our original, okay? Our image, so that's our pre-image. Our image is the image after the reflection. So after we do the reflection, then that is what is called our image. So we're going to have pre-image and image. Pre-image is the original. Image is going to be the result, okay? All right, so things to keep in mind, because I'm going to use that vocabulary a lot as we go through this, okay? Now, I mentioned this already, but reflections are congruence transformations, meaning when I reflect something over a line, it does not change its size or its shape. That is still intact, okay? So this is what we would call a congruence transformation, okay? So it means that the image and the pre-image are congruent to each other. This is also called isometry. So when you do some sort of manipulation or change to a figure and it does not change its size or shape, we would call that isometry. Or we would say that the figures are isometric. Sorry, I'm taking attendance. The only person we're missing, I think, is Liam. Is that right? I think I've seen everyone else's smiling face. Okay, cool. All right. So, how we often represent this, and I forgot to highlight this, but look under where it says image. I'm going to sit in Liam's desk today. So where it says image, that's our new image. So that's our result. Notice there is an A, and then there is an apostrophe on that A, okay? So I'm going to write this for you guys, but we are going to read this. So this would be read as A prime. So that's how I'll say that. So this is pronounced A prime, the part that's highlighted in yellow there, okay? So anytime we do some sort of transformation, we'll put in like an apostrophe on that figure, that letter, whatever it is, and we'll call it prime, okay? All right, so I got a table here which we're going to use to organize all of our rules for our reflections. And we focus on 4 main types of reflections. We'll do a 5th type of reflection as well too. We'll do that soon, okay? All right, so we talk about reflecting things in the x-axis, reflecting it over the y-axis, over the origin, and over the line y equals x, okay? Tegan, when you first gestured when I talked about reflections, you went like this. You said this, and then you went like that. Or vice versa, this, like that, either way. We could consider that to be a reflection over what axis? If I have, like, my hand is here, imagine that in the top right quadrant, and then I go like this, that would reflect over which line? It'd be my y-axis, right? So if I reflect over the y-axis, here's a question. What changes? My x-coordinates or my y-coordinates? X-coordinates, right? Because I'm taking my figure, and would you guys agree, I'm moving it in such a way, but it's also moving to the left. So because of that, that changes my x-coordinates, okay? What does it do to my x-coordinate if I reflect it over the y-axis? That's a bit tough to conceptualize, but like, let's look at this, okay? So we did y-axis first. So I'm actually going to skip to this second column right here, okay? So I'm going to fill out this column, okay? But if let's say I have this figure right here, AB, okay? What I want to do is I want to reflect point B over my y-axis, okay? Everyone looking up here? Point B, I want to reflect it over the y-axis. What direction is it going? Up, down, left, or right?
Down.
No. Over the y-axis. To the left, correct? How many units do I need to go to the left? Well, how many units is it from here to the y-axis?
2.
2. So then how many more units do I need to go to the left?
2.
Also 2. So my new point's going to be right about here, right? So we would say this is where B prime would be. Let's give A the same treatment, okay? So if A is at negative 3, 1, but I want to reflect it over this y-axis, which direction am I going to go? To the right this time. How far do I need to go to the right? 6. 3 to get to the line, and then 3 more to have an equivalent reflection, right? So it would be 1, 2, 3, okay? All right, so then we would say this is A prime. So then that red line is the blue line reflected over the y-axis, okay? Now, let's talk about coordinates. B prime, the coordinates of that ended up being negative 2, 3, and A prime, the coordinates of that ended up being positive 3, 1. So what I want you to do is I want you guys to compare B and B prime right now. Sorry, this is negative 2, and then this should be a 3. Okay. As promised, did my y-coordinate change? From B to B prime, did my y-coordinate change? No, it didn't. Because I moved it to the left.
Oh, yeah.
My y value did not change. Ryan, you were probably thinking about x-coordinate, right? How did my x-coordinate change? When you said what? It became negative. And if I look at A and A prime, does my y value change from A to A prime? No, it's still 1. What happens to my x-coordinate? Changes sign, right? So that's going to be our rule for reflection in the y-axis, okay? So my coordinate point, xy, becomes what? Y didn't change, but you're close, Haya. Negative x, comma, y. So that is our general rule. Anytime I want to reflect something over the y-axis, I just need to negate my x-coordinate, which means change the sign of my x-coordinate, okay? So the second row is how to find coordinates. We're just going to change the sign of the x-coordinate. That is what that rule means. Y-coordinate stays the same. We just change the sign of the x-coordinate. All right. We did from bottom to top. Let's do top to bottom for x-axis. You guys tell me. So if I reflect it over the y-axis, it was moving this way. If I reflect it over the x-axis, where's it going to go? Down. Like if I'm in like quadrant 1, if I reflect it over x, it's going to go down to quadrant 4, right? What is going to change? My x value or my y value? Y. The location left and right stays the same. It's just my y coordinates change. Based on what we did for the last one, how would you expect them to change?
Negative.
Negative. So what value becomes negative? Okay, that's true. But of my coordinates, x or y, which one becomes negative?
Oh,
Y. So and really, it's not necessarily, and me like asking you this is misleading. It's not that it becomes negative, but it changes sign. So if it's already negative, then it would become positive instead. Okay. So then my rule for reflection in the x-axis is xy becomes x negative y. How to find coordinates? Change the sign of the y coordinate and then let's do that in the example down below. All right, so I have that same line segment, but in this case, I want to reflect it over the x-axis, okay? So let's start with point A. So point A is here, negative 3, 1. If I want to reflect that over my x-axis, which direction is it going to go? Down. How many units? 2 units. So it becomes the point negative 3, negative 1. Which does that work with accordance to our rules? My x coordinate stayed the same. My y value went from 1 to negative 1. It changed the sign, right? I'm going to do the other one by using my rule. My other point is 2, 3. If I use my rule, what does my new coordinate point become? You said what? 2, negative 3. So 2, negative 3 would be here. So then that is where my point is going to be. Okay. Does that red line look like the blue line just reflected in the x-axis? Seems right. Okay, cool. All right. Is that a bucket up there?
Yep.
Chris, you know what you would have had to have done if you missed, right? Did I not tell you guys that? 10 push-ups. If you shoot for the trash can and miss in my class, it's 10 push-ups. All right. What is the origin? Good. It's the coordinate point 0, 0. So if I reflect something over the origin, it's going to reflect about this point. So whatever distance a coordinate or a triangle or a figure or whatever has from that point, it's going to have that same distance just in the opposite direction. Okay, so my new point is going to end up there. Now, fortunately, we have a rule for that. Okay, so here's the rule. Your point xy becomes negative x, negative y. So what that means is you negate both of your values. You change the sign of both coordinates. Okay, so how to find coordinates? Change the sign of both coordinates. I'll give a visual demonstration of B. What is that coordinate that I marked down? Sorry, you guys probably want me to leave that up here. What is that coordinate point that I marked down below? The red one. This is B prime, which is negative 2, negative 3. My original one was 2, 3. My point became negative 2, negative 3. I just changed the sign of both of those. Okay. What about for A, which is at negative 3, 1? What does that become? positive 3, negative 1. So 1, 2, 3, negative 1 would be that value there. That's going to be A prime, which is positive 3, negative 1, highest said. Okay. So that's going to be my new point. All right. Last but not least, we're going to reflect over the line y equals x. This one's tricky. So here's the line y equals x. You can think like y equals mx plus b. If I plot that where my slope is 1 and my intercept is just 0, then that means we want to reflect this point over this dotted line that I just did, okay? So in order to do that, you need to find your distance from the point that you have to that line, and then you need to draw a perpendicular line to it. This is how we like actually find what that is. So like my distance to find from here to there is with a perpendicular line, and then I need to go that same distance on the other side of that line. So then that point becomes there, which what is that point? B prime would then be at, looks like positive 3, 2. What did I do to get from this point to this point? Yeah. Yeah, you swap your x and y value, okay? So your rule, xy, becomes be yx, right? So we're going to say, I like the word that Chris used, swap the x and y coordinates. All right, and then if we play that game with the other coordinate, the other one is negative 3, 1. If I swap my x and y coordinates, what does that become? 1, negative 3, right? 1, 2, 3. So then my A prime is going to be 1, negative 3 according to that rule, which would be, if I take the distance from here to here, should be the same distance from there to there. That should be done on the perpendicular line. So that looks like it makes sense to me. All right. Questions there? There's another one that we can talk about. You guys don't have to write this in if you don't want to. But you can also reflect things over the line y equals negative x. When you do that, the rule is xy becomes, you flip the coordinate and change the sign, so it's negative y, negative x. I don't think you guys will see any like that, but for the 10 years that I've taught geometry, I always taught that rule, so I'm throwing it up there anyway. But you swap the coordinates and change both the signs, and then you just reflect it over the line y equals negative x, okay? Ready to do some examples? Let's do it. So these rules need to live rent-free in your head, okay? All right. We can also reflect things over lines that are not one of those rules, but we will do them coming up here soon, okay? All right, so example 1 and 2, graph each figure and its image under the given reflection. So we've got the segment AB, it's got endpoints 2, 4, and then negative 3, negative 3. And I want to reflect it across the x-axis. Step 1 is let's plot our figure. They give it to us in purple writing, so I'm doing it in purple. All right, so A is at 2, 4. And then B is at negative 3, negative 3. There's my line. All right. So what I'm going to do off to the left here, I'm going to write A, which is 2, 4, and then B, which is negative 3, negative 3. And then I'm going to do my rule. So we said reflect it across the x-axis. So I want to come up with an A prime and a B prime. So if I reflect something over the x-axis, what is that rule? XY becomes what? what becomes negative? Which coordinate? The y value, right? And even if you guys, like, if you're stuck and you can't remember what the rule is, imagine, like, okay, I have a point right here. If I want to reflect it over my x-axis, it's going to be right here, whatever. What changed? Did my x-coordinate change or my y-coordinate change? My y-coordinate changed. That's how I know where the negative needs to go, okay? So then my coordinate becomes x, negative y. I just need to negate my y values that I have. So 2, 4 becomes 2, negative 4. That's A prime. What about B prime? What does that become? Negative 3, positive 3. So just change the sign of whatever your y coordinate is. All right, let's see if this makes sense. So then A prime is at 2, negative 4. So down here, A prime. And then B prime is at negative 3, 3, which is here, B prime. So then my segment looks like that. Okay. Do those look like those segments are the same length? Seems like it. Okay. All right, cool. Let's do something more exciting. Triangle time. Orange. All right, triangle DEF has those vertices. We want to reflect it across the origin. All right, so take a second, plot those 3 points. You guys okay with plotting points? We good there? 3, negative 2. Is 1, 1. So D, E, F. I don't care if you rewrite your original points like I'm doing over here to show my work. You can just write the result if you want, but I just want you guys to see where all of these things come from. If I reflect something across the origin, what's that rule? Switch what? Switch both sides. So then x, y becomes negative x, negative y. Okay, so I just need to change the sign of everything that's there. All right, so negative 1, negative 3 becomes positive 1, positive 3. That's D prime. E prime would be what? Negative 3, 2, they said under their breath. And then F prime becomes what? Negative 1, negative 1. Cool, we plot. 1, 3. D prime. E prime is negative 3, positive 2. And then F prime is negative 1, negative 1. I think it's just and I shouldn't have put that mark there. It's negative 3, positive 2, Landon. I gotta get better at my threes. Me as a basketball player. I'm just kidding. I'm really bad at basketball. It's the one sport that I like never really tried to get better at. Do those triangles look like they have the same shape and size? They should. If not, that means you messed something up. So go back and check your work if it looks weird. Okay?
If they're not the same, it's wrong.
What'd you say?
If they're not the same, is it wrong?
Yes. Because this is what's called a congruence transformation. So can I rotate this at all? Or I twist it? There's gotta be a way, right? You know what I'm trying to do? Like if I do that, it's not gonna work out. I'm trying to rotate it as well too. Oh, it is resize, right? Oh, wait.
You can't rotate it though.
Can you not? Womp, womp, womp. All right, well, now I got to undo a bunch of times to get it back to where it's supposed to be. Beep, boop, 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 boop. Oh, there we go. Okay. Okay, I tried. I don't know. Technology failed us, guys. All this technology, man. All right, cool. Yeah, let's do lines of symmetry. I think you guys will find this is pretty simple. We always equate lines of symmetry as math teachers to a butterfly. A butterfly is symmetric, right? When it closes its wings, what happens? Those things line up on each other, right? Okay. So we can do that with figures as well too, and we want to draw our lines of symmetry into our figure, okay? How many lines of symmetry does this butterfly have? Like how many lines could I draw such that it'll line up on itself if I fold that figure on that line? Just one, right? Right down Main Street here. If I fold those butterfly wings, or if I close those wings, those are going to line up on each other. Fold one side to the next, okay? All right, what about this little, I don't want to call it a leaf because there's 4 of them there, right? Is it a clover, 4-leaf clover? But aren't you like, don't you normally try, is it 3, right? Like if you find a 3-leaf clover, that's like, is it 4-leaf? I just spent a lot of time outside. All right, so either way, I'm just kidding. But either way, 4-leaf clover is the one that you want to find, right? How many ways, how many lines of symmetry does this have?
2.
Okay, so let's draw them in. I've got 1 here, 1 here. I heard somebody say 4. Where else could I draw a line? Like diagonal, like here, right? That would work. What about the other diagonal? That's cool. Assuming that it's a perfect 4-leaf clover, then I would be able to find, all right, I'd be able to have 4 lines of symmetry. So then this had 1 line of symmetry. This had 4 lines of symmetry. Oh my gosh. What about that next figure? I feel like probably a lot, right? Where can I draw them at? So like the y-axis, like top to bottom. Where else? Left to right. Where else? Can I draw more?
Yeah.
Where?
Put them on all the verses.
Oh. So here, there. You guys tell I'm like really trying to be very careful. And then the other ones as well too, right, Clark? So like here, and then here. Missed one of them, right? What other? Oh, I did miss 2. You're right. Thanks, Ananya. I think we got them all. How many do we have? We have 8 of them. If you count around, it should be 8. Okay. All right. Questions there? Cool. Let's keep it moving. All right. The next type of transformation we're going to talk about is something called a translation. Okay? So we did reflections. It's no big deal. There are rules from that, whatever. As long as you follow the rules, then you'll find what those are. The next thing we're going to do are what are called translations. Okay? Which allows us to take an object and then to slide it or shift it in a direction, up, down, left, or right. Okay, so a translation is another type of transformation. It moves all the points of a figure the same distance in the same direction. Okay, so we can draw translations if we know the direction and how far the figure moves either horizontally or vertically. Okay, so if we are adding a value horizontally, which direction are we going to go? If we add a value, what do you think? To the right. If we subtract a value from our x-coordinate, where are we going? To the left. I would write this down in your notes. So this part that I'm writing right here, write this in your notes. And then vertically, well, that'd be up or down, right? If I'm going up, what am I doing? Adding or subtracting? Adding. So plus is going to be up. If I'm going down, subtracting. All right? So horizontally is right to or left to right, whatever. If I'm adding, I'm going right. If I'm subtracting, I'm going left. Vertically is up and down. If I add, I'm going up. If I subtract, I'm going down. It's going down. All right. Oftentimes you'll see it written this way, or it is written as a rule. So then this would be the rule that we need to translate, okay? They could also write it in words. So for example, that's what it says in example 4. Find the image, so the result of a triangle QRS after a translation of 4 units down and 6 units to the right. So since I'm going to the right, that's going to affect my x-coordinate. That's why I write x plus 6 first. Since I'm going down, that's going to affect my y-coordinate. So that's why it's y minus 4. Okay? All right. So then I want to do that to each one of the coordinates that is listed right there. So Q, R, and S. All right. So I want to come up with Q prime, R prime, and S prime. Now, I'm going to show a bunch of work the first time I do this, and then I'm never going to show this much work again. Okay? So I want to add 6 to all my x coordinates. So Q prime would be -4 plus 6. And then my y value, I need to subtract 4. So I'm going to do 2 minus 4. R prime would be 3 plus 6, 0 minus 4. And then S prime would be 4 plus 6, and then 3 minus 4. I'm never going to show that step again, but I just want you guys to be abundantly clear where each one of those values come from, okay? So we added 6 to all of our x coordinates, and then we subtracted 4 from all of our y coordinates because that's what the rule said. All right, so then we just need to come up with those values. So then Q prime is going to be 2, -2. R prime would be 9, -4. And then S prime would be 10, -1. We okay with that? Will that change the size or shape of my triangle if I just slide it? No, not going to change size or shape. Is that going to change the orientation? You know what I mean by that? Like which way it's facing? Is that going to change that at all? No, it just moves it. It keeps it the same. It just slides it. Okay? All right, cool. Let's do an example where we actually graph those. Okay, so we've got a quadrilateral, 4 sides. It gives us our coordinates. And then it gives us the rule where xy goes to x minus 2, y minus 6. I'm going to start by plotting my original. Okay, so where do I start? Start by plotting your original. So I like to put my points in and then label each one. So A is there, B is 2, 3. C is 5, 4. And then D is 6, 2. So then my quadrilateral looks like this. And it is silent in here. You guys are so well behaved. All right, so I'm moving it according to the rule x minus 2, y minus 6. You guys tell me which directions, plural, are we moving? And by how much? You said what, Ryan? Down and to the left. How far am I going to go to the left? Left 2 units. Down how many? Yeah. Left 2, down 6. Okay? So now what I want to do is I want to come up with coordinate points for A, B, C, and D prime. So A prime, B prime, C prime, D prime. Okay. I need to subtract 2 from all of my x values and subtract 6 from all of my y values. Do you guys want me to show more work than just writing the numbers? Or are you okay with where those come from? We're cool? Like, for example, 1, 1. What does that become?
-1.
-1, -5. Are we all okay with that? So it would be -1, -5. Again, I would go back to this coordinate right here. I would subtract 2 from the x value, subtract 6 from the y. You can always do that underneath if you want to show that. All right, what about b prime? What does that become? Right now I'm at 2, 3. If I subtract 2 from the x and 6 from the y coordinate, what's that become? 0, -3. What about c prime? 3, -2. I like it. Last but not least, d prime. 4, -4. We okay with that? Now we plot. A prime is at -1, -5. And then b prime is at 0, -3. C prime is at 3, -2. D prime is at 4, -4. Does our red quadrilateral, I'll give you a second to graph it so you can look at it yourself. But does our red quadrilateral look like our blue quadrilateral was shifted left 2 and then down 6? So if I shift this guy left 2 and then down 6, does it seem like I would end up with a red? Chris, what did I do? What did I do? Oh, I thought you had a question.
I do. Do we have to show like the stuff on the side, or can we just like put it down?
Point by point. I'm gonna want to see your coordinates. I don't care if you do this, Chris. Like, you don't have to do that. But I do want you to write the coordinates individually. The only way that I would maybe, possibly, potentially be okay with it is if you wrote the coordinates instead, like right next to each one of the points. You know what I mean? I might be okay with it there. But I am going to want to see what your coordinates are, okay? You guys know me. By now, I grade on partial credit. So if you botch something up, if you show your work, I'm going to take off far less than if you don't. Okay? Just because I'm big on like trying to figure out your mental process. Okay? All right. Video games. Did I get your attention? All right. The graph shows repeated translations that result in animation of the yellow figure used in a video game. Find the translation that moves figure 1 to figure 2 and the translation that moves figure 4 to figure 5. All right, this seems like a stretch in order to say like, hey, this represents a video game. Like, I totally get that. However, in my honors pre-calculus class, we're studying matrices right now. And I talk about how you can feed, like if you create like an image on a screen of like a figure, whatever, you do so by doing it with a bunch of different coordinate points. And then if you take an action in a video game, you move your figure to another location, whatever, that can be done using matrices. And you shift an original matrix to a new matrix using a translation rule. So like this is a very small application of like, yeah, okay, this stuff actually does happen when they code video games. Now, granted, that's if you do it from the ground up. The type of games that they make now, it's like, it's much different than how they actually do those transformations. But either way, there are some applications there, okay? So we want to find the transformation or translation that moves it from figure 1 to figure 2. All right, I know you guys can't read this. So 1 is at the coordinate point 3, -2, and then 2 is at the coordinate point 1, 1. So I want you guys to tell me what is the rule I need to do to get from my point in 1 to my point in 2. So I went from 3 to 1. How am I going to affect my x-coordinate? Good. So then I want you to write this as a rule. So it would look like x minus 2. And then what about my y-coordinate? I went from -2 to +1. I need to add 3. So then this is my rule to get from figure 1 to figure 2. That's what I want your answer to look like. Okay, so that was from 1 to 2. Let's write a rule for from 4 to 5. Okay, so 4 is at the coordinate point -3, 1. 5 is at the coordinate point 1, -3. What did I do to get from -3 to +1? Did I add or subtract? Add 4, so x plus 4. Chris is doing the heavy lifting today with the volunteer, and you guys got to help him out. What did I do to get from 1 to -3? Good. So then y minus 4. So then those are my rules. That would be from 4 to 5. All right. All right, one last thing. In the figure, lines S and T are parallel to each other. So S is parallel to T down below. Okay? Determine whether the red figure is a translation of the image of the blue pre-image, quadrilateral PQRS. All right? So what I'm doing is I'm reflecting PQRS over the line S to get P prime, Q prime, R prime, S prime. But then what do you notice if I reflect it over another line that's parallel to S? Sorry. What do you notice about my red figure and my blue figure? They're the same. And what can you tell me about the orientations? It's the same as the original, right? So we could say yes. A reflection, or I should say just reflections. So reflections over two parallel lines are a translation. So I could have gotten from the blue to the red just by shifting it to the right and then also down. All right, questions there? We feel okay about this stuff? Hopefully. Let me give you guys a worksheet. There's like 14 problems on here. I don't want to give you 14 problems for the weekend, so let me condense it down for you a little bit. How are we feeling today? Are we feeling even or are we feeling odd?
I'm feeling pretty odd today.
You feeling what?
Pretty odd today.
Odd? Do the odds.
I hope.
So no, there's one less odd.
Yeah, right. I heard that.
Are you praying on my job? Did you do that? Or is that already there?
No, I did this.
You need.
I'm going to the mall. I still remember it.
Feeling pretty odd today.
Feeling odd?
Like socks. Our old papers just all black.
Keep.
That's what it enforces.
I put
No.